All right, it's 4 o'clock. So again, welcome everyone, and thank you very much for joining today's webinar on Space for Forestry. My name is Remco Timmermans, and together with my colleague Cornel Bolgaert of Eurisy, I would like to welcome you to this webinar. This webinar today is part of a monthly series of webinars by Eurisy and the dotSpace Foundation on every first Wednesday of the month. The main theme for this webinar series is space opportunities for climate challenges. We talk about different topics within the climate challenges every month, following the same structure. In this series, we bring together government, education, and the industry to find connections and opportunities, introduce experts in the field, learn about new funding opportunities in Horizon Europe and other funding opportunities, and hear pitches of organizations active in the field. Now, before we start, I would like to point out a few technical remarks. I'm assuming you're all familiar with Zoom, but just to point out a few things. This webinar is being recorded, so if you miss parts of it, or if you join late or you have to leave early, then you'll find the recording of this webinar on the GroundStation, dotSpace and Eurisy websites starting tomorrow morning. Also, the presentations that you're going to watch today will be visible there from after this webinar. I encourage you to use the chat function to introduce yourself, to ask questions, to talk about anything you would like within the topic of this webinar. Please make sure, because this is a webinar, not a Zoom meeting, that you select all panelists and attendees rather than just all panelists. Otherwise, your fellow attendees, participants will not see it. And I would also like to highlight the fact that I would like to invite you after this webinar. The webinar is not over in an hour, but after the webinar is over, we have a forum where you can continue to ask questions and interact with each other and with our panelists after this webinar, really 24/7. So what are we going to talk about today? The structure of this webinar is as follows. After this short welcome, we will introduce the topic to you. We'll go through a few news and events. Then we'll have a few specialist speakers in the field of space for forestry. We'll talk about funding calls, funding opportunities within the realm of space for forestry. And then we'll hear 4 short pitches by organizations and people who have questions or short introductions around the topic of space for forestry. Let me very quickly introduce GroundStation dotSpace for you, also known as the dotSpace Foundation, one of the 2 co-organizers of this event. dotSpace is really an open innovation network where we link the world of space data to all aspects of society, including forestry that we're talking about today. We show opportunities of space data to non-space sectors. We bring together academia, industry, and government, and we share news, events, workshops, how to access data, etc. on our website, GroundStation.space. And our other partner, I would like to introduce Cornel.
Thank you very much, Remco. So allow me please to share my presentation. So there we go. So again, very welcome also from the Eurisy side, and we are very pleased to again today to raise awareness of satellite applications within this topic of climate change. And it's important for us to facilitate indeed the dialogue between both space and non-space communities, and to give also the feedback about potential barriers in the uptake of satellite-based services. And we do this on behalf of our members. So these are mostly space agencies across Europe. So if you would be interested to join the Eurisy network or to partner up with us, feel free to contact us. You can find our contact on the slides, or you can just visit our website. And of course, you will also get access to these slides after the webinar. So now about this series of webinars, so space opportunities for climate challenges. So our last or most recent session covered the renewable energy transition. You can find all about that on the Eurisy website. We have a very nice recap article with all the presentations there and the short fragments of the recordings you can also find on the, in this article. But today the topic is forestry. So a few months ago, there was this State of Europe's forest report, which included both positive and negative outcomes. So maybe first a bit about the positive aspects. So what we see over the last 30 years is that actually the European forest area has increased by 9%, and also the volume of wood and the weight of carbon stored in the European forest have grown significantly. So that is very good. Also wood supply, and yeah, also the same is true for at least biodiversity conservation, which has increased by 65% over 20 years. However, there are still some challenges and pressures from societal demands, but also climate challenge or climate change impacts. I mean, there's the usual risk of fires with extreme droughts, heat waves, but also other challenges such as insects, diseases, and then of course also air pollutants that can locally still exceed critical loads. And in general, there's a relative low net revenue for forest enterprises, which was a risk for forest management. And as you might be aware, forests are indeed a very important sector. So this includes both for instance, the paper industry, but also for wood production of the timber, of course. And then, I mean, as I just mentioned, it's also, of course, a very important carbon sink. So it's very relevant for today's environment and our whole climate challenge. And so the Confederation of European Forest Owners is of view that sustainable forest management implemented by European forest owners and managers today is really key to tackle the challenges that forests are facing. And so within this context, we will present today the role or the importance that space can play in this setting. So think of, for instance, Copernicus data, which provides periodic coverage for forest monitoring. So again, very important today for environmental protection and relevant for forest in the fight against climate change. So on these slides, you can find some of the links. So again, these will be made available after the webinar. You can register to a link where you have access to all the past recordings and presentations. So our first session covered plant health and biodiversity, which is close to the topic that we will discuss today. So for instance, we talked about monitoring plant species, so invasive plant species, also the detection of illegal oil palm plantations. So you can find more about that following this link. And also today, we are very glad to have Tessello, which was featured in this recent Sentinel benefits study. So we will also cover that, but if you want to have a look in more depth, you will find the link here. And I would also like to refer to the Copernicus market uptake, which was a report published back in 2019, but nevertheless, it has quite some relevant information about market uptake of Copernicus data, more specifically on page 50, where you can find a section about forestry. And then on my final slide, I would also like just to raise the point of our success stories on the Eurisy website, where you can really find diverse range of satellite applications. So from mapping services to, again, monitoring the risk of fires, to monitoring illegal deforestations, and even other applications such as for geolocating trees for educational purposes. So you can find more information. And again, these are all linked. So if you can find my presentations after the webinar, you can just follow the links, click on these images, and then get to the success stories. So Remco, I hand it back over to you now.
Thank you very much, Corneel. And I will take over the screen again. real briefly, before we go over to the speakers, I would like to share a few news items that hopefully as specialists in the forestry area you might be familiar with. But just to highlight a few things that I think are interesting to read. First of all, it's been a while already, the 2020 Copernicus and Galileo Masters, but I always like to highlight some of the winners in relation, in this case, to forestry and Earth observation. That I think offer interesting new innovations in this field that are worth looking at. We have 3 Copernicus Masters winners in 2020 that are related to forestry. So by all means, have a look at those. Then also because in a previous life, I was involved in the Forestry Stewardship Commission in FSC. They have now launched a new GIS portal, at the moment only available to certifying bodies, but very interesting how an organization like FSC is now including space data for sustainably monitoring and managing their forests. And similarly, Planet, together with KSAT, Airbus, and the Norwegian Institute for Forestry have introduced a new product about a month ago, where they will make forestry data available for the tropical regions to anyone who wants to use that information to help us protect and manage tropical forests around the world. So a few interesting links that you can read more about when we publish these presentations after the session. Then a few events that might be of interest to you, again, on the crossroads between Earth observation and forestry. First one is the IGARS, the International Geoscience and Remote Sensing Symposium, which is a generic remote sensing symposium in July that is held in a hybrid mode this time from Brussels, but you can join online as well. So that's in July. There's an event more specifically going on about bark beetle calamities for forestries in Central Europe called the Forest's Future. That is held towards the end of this month from the Czech Republic, but of course the event is online in case you're interested in that area. And then a little preview for next month's session with Eurisy and dotSpace, our next topic within the Space Opportunities for Climate Challenges webinar about smart mobility, but I'll come back to that later. So now I would like to hand it back over to Cornel to introduce today's speakers to you.
Yeah, exactly. And so the first speaker of the day will be Bojan Tubic. So he graduated from the Faculty of Forestry of the University of Belgrade, and he holds a PhD as a forest engineer for the Serbian public enterprise Vojvodina Šume. And throughout the years, he became engaged in different activities, including forest planning, development of strategic forest management, and implementation of GIS projects. And he participated in several European and international projects as well. So please, Bojan, you have now the floor.
Thank you. Thank you for the opportunity to speak at this webinar. Also, thank you, Cornel, for this introduction. I will share the screen now. Okay, so this presentation is about remote sensing application in forest management to optimize forest functions. But first of all, I would just say a few words about the concept of forest management, which refers to the process of planning and executing practices for the administration and use of forest and other wooded land with the objective of meeting specific environmental, economic, social, and cultural objectives. In other words, forest management refers to the management of forests in accordance with the principles of sustainable development. There is a wrong perception about forestry, public perception of forestry and foresters, which are usually considered as someone who just felling and cutting the trees. But this is far away from the truth. Sustainable forest management is all about ecological values, social, cultural values, and economic values. So all these aspects are equally represented in the sustainable forest management. And also to the forest are related ecosystem services like water purification, carbon sequestration, provision of food, fiber, and fuel, habitat for organisms, and many others ecosystem services. These ecosystem services in the forestry are known as forest functions. Actually, these are demands of society toward the forests. And the position of forest manager is very difficult in that sense. Forest manager must organize forest management in a way to fulfill all these demands, or at least the most of them. The situation is more complex when we take into account the climate change. Climate change is increasing the frequency, intensity, and the magnitude of disasters, leading to a higher number of deaths, injuries, and increased economic losses. This is especially reflected to the forest, and at these pictures, there are some examples of negative effects of climate change. In the past 20 years, 90% of major disasters have been caused by weather-related events such as heat waves, storms, floods, and droughts, according to United Nations Office. We need to increase resilience to disasters and climate change, and on the other side, to decrease vulnerability of forests and ecosystems. On this map, you can see the forest area, which is managed by public enterprise, where I'm coming from. This is area of Vojvodina with very low percentage of forests, only 7.1% of the total area is forested, and this means that forest has even more value for that region because there are not so much of forest. To face all and to cope with all these problems and challenges, we are using in our enterprise a range of technologies and a range of Earth observation data, like orthophotos, satellite images, drones, which are also used for the collection of orthophotos and near-infrared orthophotos. Then we use specific softwares for the classification of remotely sensed data, etc. All this we are using to monitor. One important aspect is the monitoring of disturbances. Generally, consistent high frequent information on disturbances is missing on the larger level, larger scale. The need is emphasized by the Green Paper, by the Standing Forestry Committee, and in the EU Forest Strategy. Types of disturbances which are monitored are fire, storm, drought, biotic damages, significant harvesting operation. Source are aerial photography, satellite images, and result is damage indication map. It is important that we monitor through the period of time, so we need frequently to have frequent images from the different periods of time. In our company, we also use these satellite images and orthophotos to have information about damage caused by wind, by climate change, forest diebacks, and also damages caused by recent fires. So why we use that? Because this is we decrease the cost of collection of data, we increase accuracy of data collected, and we are able to get some additional information. And what is the most important, we are able to respond quickly to get information very quickly in opposite if we do this on some other way, on classic way with field work. Just few final remarks. Good decision require a good information for the planning, monitoring, reviewing at all levels, local to national to global, and we need to do adaptive management, sustainable forest management, respecting criteria and indicators for sustainable forest management, and we need a multi-stakeholder approach so that all stakeholders are taken into account during the forest management. And just last slide on the Copernicus program, although it was mentioned in an earlier session, there are a lot of freely available data. I would emphasize tree cover density and the forest type, this high resolution layer with 2 additional products, tree cover presence and dominant leaf type. These products are being produced in 25 meters, special resolution. So this is not for the operational work, but for the larger scale projects are very good data. And our company also participates in some international projects, and we use this data for that purposes. And I would recommend to use this opportunity. Thank you very much.
Thank you very much, Bojan, for your presentation. And I would also like to remind the audience that they can now use the chat for any questions they might have. So we will have a short Q&A session after all the presentations. So I kindly invite everyone to use the chat or the Q&A tab for any questions. So now I would like to continue with our second speaker of the day. So next up we have Mikko Stralendorf. He has a Master of Meteorology from Helsinki University, and he was the head of the Information System Services unit at the Finnish Meteorological Institute. Mikko is a ministerial advisor in Finland's Ministry for Transport and Communications, and he also worked as a European Commission representative for the Global Monitoring for Environment and Security Bureau, coordinating the development of marine atmosphere and climate change services. He was the European co-chair of the Earth Observation Working Group for the EU-Russia Space Dialogue, and his main work is currently on climate services with seasonal forecasts for the forestry sector using satellite data. So today he will present the pilot Forestry Conditions, Climate Services within eShape, which is a European project fostering the development of Earth observation services. So Mikko, you have now the floor, please.
Thank you very much, Cornel and Remco, for having this opportunity. So eShape, as on the slide you can see, is actually a project that has 27 pilot services organized in 7 different, let's say, showcase areas. And I'm actually leading the climate showcase area, but I have been also very much involved in doing this harvester seasons forestry planning service. And that's what you will hear about now. And sorry, I have to, of course, go to the... Now I can change the slides. So the service is really about forestry conditions, and probably the best term is to say trafficability in forests, because forestry machines, when it's a business, at least which is the case in Finland and Sweden, and well, most forests that are being really used in an economic way, they have been worked since decades now with forestry machines, which are actually pretty heavy, something like 20 tons. And what the bad, let's say, situation is that these big machines do compress the soil in the forests, which of course is not good in many ways, but especially also for the fact that the forests don't grow if the soil is too compacted. So to do these forestry activities, you should find conditions where this does not happen, or at least it doesn't go very deep. And our service is trying, with the help of something which is very much an Earth observation-based product, which is trafficability in a static sense. So which areas are prone to high moisture of the soil, or which areas are let's say peatlands, and which areas are having a better ground soil type. So we are adding to this the weather information. So how does that kind of effect that comes from temperature being cold, and we get frozen soil, or we get snow, and then on the other hand, the precipitation, how it stays in the ground. And yeah, this is a service where the Finnish Met Institute mainly is the actor, but the University of Helsinki is also adding a carbon emissions impacts part that's not yet in the service, but will come during this project, because eShape has been now around for almost 2 years, but it's not finished. It will go 2 more years. So let's go to the service, harvester seasons. So we have been online since May 2020. And the kind of real idea here is that we use seasonal forecasts, which means 6 or almost 7 months ahead, the kind of probabilities in weather that really say, and we calculate it into having a good conditions for doing forestry or having a bad condition, and then we leave some area in between that is uncertain because the forecasting is not that kind of like how do you say, it's not like that good, but I would say that it's not yet that reliable that we could say in all conditions far ahead in the future how it goes. But we really a lot rely here on the Copernicus Climate Change Service, because that's where the seasonal forecasts come from. And really the main idea here is that 51 kind of weather forecasts far in the future, we then group them together. If 90% of them are saying good or 90% are saying bad, these are the sure conditions which we highlight. And then the uncertain leaves the static map, which you can see here in the picture, that you always on this web page really drill into a site where you can see on a 16-meter pixel, let's say, accuracy, different static conditions, and our forecast then changes them to good or to bad, kind of depending on which either winter or summer conditions are good. And as these seasonal forecasts are quite coarsely run in principle, it is really important that we have also bias adjusted them. So we have been using the 2000-2019 climate, in particular the ERA 5 reanalysis information for land. This is on a 9-kilometer scale, and that's how we have downscaled, so we get more precise information per location to these seasonal forecasts. Yeah, and in essence, this kind of means that we have a timeline 6-7 months ahead for this point where you have been clicking, which then predicts to you at what time in this period do you have a good condition and when do you have a bad condition, so that they could plan much more ahead when currently they usually plan a week ahead or something. Can they go and do a forestry action or not? And this gives them much more longer planning kind of horizon. And we also, of course, include here, for example, the Finnish maps for all the areas are pretty detailed, and that helps for doing this kind of, for example, here could be a parcel that if you go to this parcel, you have some swamp here, you have some ditches in here, where is the closest dirt road, or where is the kind of more real road, and where is the highway, for example. These kind of details the forestry operators are interested in. So we have tried to combine them in this app, but to not kind of like hide from them the pretty kind of problematic big data behind it. We have been also showing them then, when in this case we use soil wetness, soil temperature, and snow height, that those are the main, let's say, factors that give us something. We are actually showing them all the 51 different graphs into the future for these, because that kind of like that they are not illusioned into what do they get. And we are also showing here that on a monthly basis, we have this bias adjustment. So we have not been smoothing it nicely, but we are showing it per month. So it is kind of more clear to a user, where does this logic come from? Is it from the climate side, or is it from the seasonal forecast side? But in that sense, it really is a service that we have co-designed with some forestry operators in Finland. We have actually quite a really good survey that people understand the service, are happy with it, and new companies have actually been very interested to use it more broadly and much more. We actually have, since the launch, already been able to expand and improve many things of it. So the end users wanted to have forest fire warning information included on this site. So now you can also check out actually the EFIS forest fire information for the next 10 days in this service. You can know the area where we calculate this information for is now all of Europe. Of course, only this Finnish part has the very detailed trafficability maps, but we are looking into how to expand that more. We have improved our bias correction part. We have improved, for example, the snow depth information, because this was a nice example that when the January forecast in Finland started from very little snow amounts, but we actually all over the country got very quickly 50 centimeters of snow or more, then of course the forecast looked pretty unrealistic into the near future when this was not taken into account. So we now have fixed from observations the starting point, so that we are giving a much more kind of logical kind of transition from the current to the forecast. And actually the tree cover density layer that Bojan already mentioned, which is a 10 meter resolution nowadays for 2018, this can be also checked on this on our service. So yeah, that's it, and thank you for your attention. And that's one of those big machines, just to get the feel about them. Thank you very much.
Thank you very much, Mikko, for that. So maybe let's move on to our third speaker. So again, just if you have any questions, please feel free to use the chat. So now let's move on to the third speaker of the day. So Edda Loonen holds a PhD degree in mathematics and physical sciences with a specialization in astrophysics from the University of Groningen. After spending a couple of years as a researcher at the University of Leiden, he joined SNT in 2012 as systems engineer and project manager. Currently, he is the group leader of the Decision Support Solutions group at SNT, and he has more than 6 years of experience in managing R&D projects, many of which were international and European collaborations. So as project manager for SNT, he will tell us now more about the SylviSense project.
Thank you, Cornel, for the introduction and for the chance to say something here. Indeed, at SNT, I work on projects to develop new applications for satellite data, and today I get the honor to present SylviSense, which was a product line developed actually by our Norwegian office. So I have to give them the credits for the work that I get to present. So SylviSense is a line of products that is aimed at forest owners and is aimed at automatically monitoring the state of forest and automatically detect and track changes in that area, like clear cuts, disease outbreak, forest fires, altered land use, or anything that is of interest of forest managers that may need further investigation or things like that. Given the time, I will not go into details of how it works. That would be I think a topic all by itself. But there's essentially 3 steps to how SylviSense works. Of course, it starts all with the satellite data that needs to be pre-processed. It needs to be corrected geometrically. It needs to be aligned, etc. And then it goes to the next step, which is really the core of SylviSense, which is a number of machine learning algorithms where a couple of main things take place. One is cloud masking. We've developed quite a sophisticated cloud masking technology to really make the most out of the data that is available. Various classification algorithms to really look at what can you see in these forests. And of course, based on that, automatic change detection. The last step, probably the most important one, is verification and validation. We spent a lot of time validating the results of these algorithms to make sure that what they predict is actually correct, and then use these results to further improve the algorithms to really boost the reliability of the algorithms. So that's as far as I go with the technical details. I thought it would be better to just show examples, because I think that speaks much more to the imagination than flowcharts or equations. So as I said, an important part is the cloud masking. You can imagine forests tend to grow in places where there is precipitation, so there will always be clouds in the images, and they can influence the information in the individual pixels. So what we've developed is a method to determine, not in a binary fashion, whether there is a cloud or not, but per pixel, we look at what percentage of that pixel is covered by clouds. And that way, we can really optimally combine data through time by looking at how much percentage of the image is influenced by clouds. So to what extent can you still use information in that pixel, and how can you best combine them? So this is a very important step to improve the reliability of the data. Then the basis for everything is a land cover classification. So here you see two images, a Sentinel-2 image on the left, and then on the right, that image is classified in various classes. Each of these will have, again, subclasses, but it's not important. And essentially, this allows you to make a distinction between urban regions, or let's say transport infrastructure, and things like areas with vegetation, water, or bare soil. So the things that really matter when you are talking about the context of forestry. Once you have done this, that's when you can do the interesting things. The obvious thing to do, of course, is look at changes in this classification. So this is an example of the detection of clear cuts. Essentially, you look at, were there trees before and not after? Is that change consistent over time, or is it perhaps caused by an artifact in the image? So really look at the time series on that. And based on that, you can make these let's say, confidence intervals that you see here. So the various outlines are levels of confidence that there was a clear cut. And this was also validated, and this method can predict with a very high accuracy. I think it was about up to 80% of the cases, this is an actual clear cut. So this way, you have a fully automatic way to detect whether in a forest area you have clear cuts. So this is very good input for inspection, for instance, of forests. More advanced application we're working on in Portugal is actually to not look at just is there forest or not, but what is the state of the forest. And in this case, the project focused on diseases, the pinewood nematode, that has a very specific effect on the development of the tree, and that translates into a very specific effect on essentially the color of the tree. So the response in the color of the pixel of the forest. And so again, using a neural network, you can train that to pick up these changes, and then you can make these maps where you have sort of a probability of disease outbreak. And that can again be input for follow-up monitoring, for instance, by dispatching drones to look at greater detail or on-site inspections. And of course, in the process, you get all kinds of interesting side products. You get, of course, again, maps of where there is forest and where there's not, but also other properties, like we're looking into also fire damage to forest, because that also has a very clear signature, of course, in what the forest looked like. So very nice follow-up, let's say, more advanced way of processing the data. Another sort of byproduct of all this is, since we have all these time series of data, we have all the information on the data quality of each pixel through in each time interval, we can also make what we call geomosaics. And essentially what you can do is say you want a map of Norway in summer, then we define an interval of those months. We check which are all the data tiles that are available, and then using this information on the data quality, on the cloud cover, etc., we sort of combine it to the best possible mosaic, which can then be input for other products, other services, scientific studies. So you really get very high quality maps with that. Here's an example, and on the right, the various colors is all the different maps and parts of maps that were used to create the image on the left. So it's sort of a necessity for us to create this to do our service, but of course in itself is a very nice nice product to use. And then lastly, not quite satellite data. You can of course do the same thing also with aerial photography. And the advantage there is a much better resolution. This example is 20 centimeter resolution, which of course is an incredible increase with respect to satellite data. And because of that, you can also go further than that. So you cannot only say is there forest or not, but we can say what type of tree species it is and the growth stage that it is. So it allows very granular insight into the forest and has, again, many applications from forest management, monitoring how natural areas recover after disasters, all kinds of things. So it allows very detailed study of forests. So yeah, these are just a number of examples of what we can do with our SylviSense technology. It's not a product that spits out one thing. It really is technology that can be applied in many use cases. So very happy to hear if this triggered any ideas. And if so, feel free to contact me or any of the people that are listed here. And thank you for your attention.
Thank you very much, Edda, for your presentation. And indeed, let's see if this triggered any ideas. So I do not see any questions for now, but yeah, again, please use the chat for this. And I will also invite the other speakers if they would like to, or if they have an idea or a question to interact with the other presenters. But now let's maybe continue to our final speakers of the to our final speaker of the day. So Marine Oudguet-Royo, she holds a master's degree in international development economics from the Paris Institute of Political Sciences, and she also studied and worked in Argentina, Colombia, Equatorial Guinea, and finally Portugal. So Marine has 10 years of experience in international project management and strategy consulting for green tech. And in 2017, she co-founded the company Tesalo, where she currently works as Chief Sustainability Officer, overseeing the development of new applications and managing partnerships with academics, NGOs, and institutional stakeholders. So Marine, I invite you now to take the floor and to present your case.
Thank you, Cornel. Thank you for having me. Can you see my screen, the first slide of my presentation?
Yeah, we can see it.
Okay. So I'm Chief Sustainability Officer at Tesalo. We are a green tech company based in Portugal. So in a nutshell, we were founded in 2017 in Lisbon, and our goal is to help organizations become more sustainable using open space data and AI. So our bet is really to focus on free data, which is why we are currently working mainly with the Sentinel program, and in particular Sentinel-2 and Sentinel-1. So our technology, well, is pretty similar to what you've heard recently with SylviSense. So we ingest raw satellite imagery, we automate all the cleaning, atmospherical correction, and we then run our proprietary AI model to reveal the insight that will best fit our clients' needs. So today, We have also developed our own proprietary platform, and we deliver all the information through this. So our main sectors of applications today are forestry, so timber producers in Portugal and abroad, and infrastructure monitoring, managing the vegetation around critical infrastructure to prevent encroachment, forest fires, etc. I'm going to focus today on our use case in Portugal with CELPA. CELPA is the Portuguese Association of Pulp and Paper Producers. So in Portugal, it's a critical area because it covers about 200,000 hectares and which are widely spread over the country, which makes it very complicated and expensive to cover and monitor by hand or by field visit or by drone. Our history with CELPA goes back to a few years ago. So we started with, it's a really long-term collaboration. We started with pilot projects about pest detection and tree species differentiation. And we are now up to a subscription basis. So we have a long-term contract with them, and we monitor the 200,000 hectares of plantations on a monthly basis, actually on a continuous basis. So the first phase is a national forest inventory, and they monthly get these 12 classes land cover with, of course, the species that interest them. We also provide an estimation of the cut areas of the burned areas because Portugal is particularly prone to forest fires. And next year, well, this year, we're going to start developing some extra features. So differentiating tree age to help them forecast their production, growth, etc.
Apologies, apologies, Marine. Sorry to interrupt you, but I think we're still seeing the same slide. So we're still on slide 1.
Oh, okay. So you're not on the right. I'll share my screen again. What can you see now? Land use?
Yeah, now we can see it.
Okay,
Perfect.
so I'll just go back. You have just, well, that slide was pretty easy. It's the very short description of the technology from a raw to a very clear image that we make accessible through our platform on the right. This is the classification for CELPA. So 12 classes, 7 of them are forest, and we aim at reaching at least 20 classes by the end of the year. As you know, for each new tree species, we of course need training data. And this collaboration with the pulp and paper producers is really strategic because it gives us access to very diverse and excellent quality training data. Land use, land cover. So here, I'm just going to give you some visual examples because that's really more interesting. So we use time series deep learning, which makes our analysis aware of the historical context. So we differentiate land use and land cover. The timber producers are interested in land use. So in this example, on the first image, we classify pixels not according to what we see today, but according to their what they are in general, regardless of the seasonality. So on the left image, on the top image, for example, you can see recently logged areas. But even if they have been logged, we still classify them as eucalyptus, because we don't want because we want to account for the total area of eucalyptus at a precise moment. Same way. So here, another interesting feature that was requested by our customers is the cut monitoring. So they know, CELPA being an association, it gathers all the pulp and paper producers of the country. And for CELPA, it's very useful, instead of requesting the information to each member, to have access to an aggregated information of what has been cut this month in Portugal. So above the satellite imagery, the RGB images, and below what our model outputs. So as you can see, it's rather accurate. Same example with burnt areas. So we now have, I think the accuracy is around 94% of accuracy for detecting bird versus cut areas to differentiate them. So at 10-meter resolution, you see from June to July the extent of a fire that took place in Vila do Bispo in Portugal last year. And the third image is the output of our model. Now, some perspective. The first one is on the tech side. Our most recent scientific breakthrough, I would say, is the implementation of a super resolution model. So it's the same feature that, for example, Google used to enhance the resolution of a face. I don't know if you have seen this example recently. It's been trending. So a very blurry image can be rendered more smoother and more accurate by the super resolution model. So that's what we are doing, which means that concretely, we train our models not only with high resolution imagery. This is only possible because some of our clients in the infrastructure sector shared with us some LiDAR campaign data that have been conducted. So we train the model with data high resolution at 40 centimeters. And then we run the algorithms, the models, to detect forest on Sentinel-2 images, 10 meter, and the output is actually 1 meter. So it doesn't mean that the final accuracy is going to be at 1 meter. In general, we are now around 3 meters, which means that the forest line we can be off by more or less 3 meters. But it's still very useful, for example, to monitor the compliance of distance between forest and power lines. A 3-meter resolution makes a huge difference compared to 10-meter resolution. So that's what we've been developing recently. We want to apply it to more and more. We want to apply to all our services. So this is another example, actually, with a power line, high resolution, Sentinel-2, and the model output. What's next? Still in the forest area. Well, we want to work more on fire risk. So we are part of a research consortium of 20 members in Portugal, including the timber producers, but all other forest owners, public universities, researchers, Superior Institute of Agronomy, etc. To develop an integrated management of forest fire. We will be providing remote sensing data. But we are also prospecting other environmental forest applications. We want to work in the forest insurance sector, penetrate maybe the market of carbon offsetting with measuring carbon sequestration, and other monitoring of reforestation projects. We are open to proposal of collaboration. For example, we are giving access to our platform to a research center in Portugal, and we are happy to explore that kind of sharing with public entities, but also complementary applications from startup or any kind of stakeholder. Thank you very much, and don't hesitate to reach out to me, marine@tesselo.com.
Thanks a lot, Marine, and yeah, thanks a lot also to all of our speakers. So I see quite a lot of activity in the chat, but not any specific questions for now. I don't know if anyone from the speakers wants to address a question, or maybe someone from the 1-minute pitches, because we also have still some 1-minute pitches at the end of this webinar. So if you have any ideas or questions, please feel free. If not, then we can, I think, move on, because we are a bit over time and we still have some things to cover. So I give it back to Remco now.
Yes, thank you very much, Corneel. And I'm not going to hold you up very much longer. I'm going to move on straight to the next speaker, who is a recurring speaker. If you've joined us before, you've seen her before. We have our ground station dotSpace specialist on funding calls, Linda van Duivenbode, who will now tell us about the relevant calls that may be interesting for our attendees on this topic. So, Linda.
Yes, thank you, Remco. I will share my screen. Can you see the slides?
Should be coming up. Yes, we can see your screen with 4 different windows on it, not specifically a slide yet.
Oh. How does that work then? I have my presentation on my screen, but
I can take it over if you want.
Yeah.
I can present it from my screen here
Yeah.
if you want. Let me just share that from here. So
no, I don't even.
no, don't worry. I will take it over. You want to continue? Yes, and I will take it from here. So here we have your presentation on my screen, Linda.
Okay. Yeah, so there's actually quite a few. Well, I say this every month for those who come back every month. Horizon Europe is the upcoming program now for research and innovation projects in Europe. It has been agreed in the sense that the overall program has been agreed with all the topics, but the work program, so the element of the program where the individual calls are launched, is not yet open, is not yet in the public domain. This is expected somewhere around April, May. Nevertheless, there is already an indication of the topics that will be coming up, where we can search. So if you go to the next sheet, Remco, the main ones that if you are looking yourself at Horizon Europe, you will have seen that it works in clusters. So there are 3 pillars. Pillar 2, there are a number of topical or thematic clusters. And cluster 6 is the cluster for food, bioeconomy, natural resources, agriculture, and environment. And there you will see that there are a lot of topics that are related to forestry, one way or the other, and quite a few of them, because forestry is so inherently spatial and good to view from like above, will be also relevant for Earth observation or remote sensing techniques. So you'll see the first one here on the screen, which comes under the destination. This is a new thing again in Horizon Europe. They talk about destinations. Destination biodiversity and ecosystem services. I've just briefly listed the call topic and the description and the type of action. So this will be a research and innovation action. And the Commission is likely to look for a project around about 8 million euro. I highlighted in red, I don't know if I did it all sheets, the one, because the work programs are multi-annual. So this is an indication that this is also one that is expected to come out in 2021, so in the first year of the first work program. Next sheet, please, Remco. Right, so this is another destination, destination 3, circular economy and bioeconomy sectors, safeguarding the multiple functions of EU forests. Here you'll see that they're not expected to come out until 2022, so it's a bit further forward in time. That's of course unfortunate if this is a topic that you would be particularly interested in. On the other hand, it does give you a good opportunity to really look at the scope of the call, build the consortium, and really fine-tune that proposal to a winning consortium. These are both, this one is a research and innovation action. One project will be awarded of around 4 million euro, and the second one is an innovation action. So it has a higher readiness level, it's supposed to be more towards the market. And that's 2 projects will be awarded or expected to be awarded of around 6 to 8 million euro each. Next one, please. And don't worry, of course, I say this every time as well, there is no way that you can copy down those references or the call topics, but we will be sending the presentation to you afterwards, and you can have a look at them in your own time. Destination 5, still under the same cluster, so still under this cluster number 6, land, oceans, and water for climate action. These are 2 that are coming up again in this year's work program, agroforestry and science-based knowledge on EU forests. The first one, again, research and innovation action, so that's slightly further away from the market. 2 projects are expected to be awarded of around 4 million euro each. So you see that certainly compared to the Green Deal calls, which we had at the end of last year, which were very big, which are like 8 to 15 and even 53 million euro. In some cases, the Commission has gone back again to somewhat smaller tickets per project, which makes it a bit more manageable also for smaller consortia with a very clear focus to bid for. And the second one, again, 2 projects of around 5 million euro each, also research and innovation action. Next one, please, Remco. Still under land, oceans, and water for climate action. So this one has a lot of interest in forestry topics. One in 2021, one in 2022. The first one is a part of the international cooperation scheme. So this one is focusing particularly on collaboration with China. This will be a bigger project, again, a research and innovation action of around 10 million euro, looking at the resilience of forests. The second one, back to Europe again, a European observatory. That's a research and innovation action where they expect to award 1 project of around 15 million euro. So having said earlier that they're looking for smaller projects, I'm now countered by these budgets, which are slightly bigger again, of 10 and 15 million euro. Next one, Remco. Yeah, still cluster 6. So this is all just one cluster within the Horizon Europe program. This destination 6, resilient, inclusive, healthy and green rural, coastal and urban communities. You see, of course, also the reference in the call topic, whether it's climate, in this case, communities. So this is more of a community activity. Smart XG, the last mile and edge solutions for remote farming in rural areas. That's also a research and innovation action, for which the Commission expects to grant 2 projects of around 5 million euro each. Next one, please, Remco. Yeah. And then to go for something different, in addition to Horizon Europe, we also try to look at programs that are also offering opportunities. For example, the LIFE program, which is a program under DG Environment of the European Commission, is likely to have some interesting topics, but the work program for that is not available yet for us to see. But focuses more on demonstration projects, so we'll have a look at that as soon as it comes out. This one is from the European Space Agency under the EU Science for Society theme. It's a permanently open call for proposals, so there's no deadline. The focus is on communications, but really with the combination with other assets as well. And this is to rapidly respond to innovative ideas that consortia may have. So I've listed here the different topics that you can look at to cover your idea. If you already have an idea or you have already a service and product under development, you can see where it fits best. So obviously, resilient society, it could be an interesting one. Grand challenges is obviously also one that fits quite a lot of, for example, the presentations we have seen earlier. And this is a firm fixed price of up to 150,000 euro, and the project duration is 12 months. I have included the link to the ESA EMIT school. So when you get the presentation, you can click the link for the proposal documents. And ESA, of course, has its own members, so not all EU members are necessarily member of ESA, and not all countries that are associated with Horizon Europe or the EU are necessarily member of ESA. So you need to really look at the countries that ESA lists in all of its tenders to see whether your country is eligible. And that's it for this month. I know I only have 4 minutes, so I try to keep it really short, and I had a lot of calls to cover. Again, you will be sent all this information afterwards, and you can always come back if you have questions. You can join the forum to discuss any of the topics. If you would like to start building a consortium in preparation for these calls, they're not out yet, so it gives everyone a little bit of the time to really see where your strength is, where additional partners can come from to build the right consortium for these calls. Thank you very much.
Okay, thank you, Linda. Again, you will be given these presentations later. I'm sorry we're running a little bit over time, but we just keep running if that's okay with you. So hang on, because we will, of course, give our last 4 one-minute presentations a chance to present their case. So without further ado, I'd like to move over to the 1-minute pitches. And we will start with Jukka Mittinen of VTT Finland to talk about ftep.com. So Jukka, the floor is yours.
Thank you. Can you?
Yes, we can see your slides. So off you go.
Okay, great. So I will go very fast. So my name is Jukka Mittinen from VTT Finland, and I'm here to highlight the Forestry TEP, which is an online platform designed for EO-based forest monitoring. This is one of the thematic exploitation platforms initiated by ESA a few years ago, and it's specifically an application platform. It fits between the large storage systems like Creodias and the user, aiming to maximize the usability and benefits of cloud processing for forestry stakeholders. So you can use either the applications that are available on the platform, or you can create your own applications. You can share applications or license commercial applications through the platform. You can use it through graphical user interface or REST API connections. And you can find all the information on the website. The image here is actually a new website, which is going to be launched any day now. You can start using it yourself, but we are also happy to collaborate in projects with you. We have a lot of experience in cooperation in different kinds of projects, and I have highlighted here, for example, 3 different projects where Forestry TEP is in a key role. Or you can bring in your business, either by licensing applications or using the platform as a backend for your processing through the REST API connections. And all this can be funded through the network of resources, for example, and other means. I think I have used my minute, so I'm very happy to. Now you can contact us for further information through the website. Thank you.
Thank you very much, Jukka. And I will put the URLs of these different organizations in the chat for you to see. And of course, you will get the presentations. I would like to hand over now to Federico Fanciamore of Space for Good. Federico?
Yes, thank you. You should be able to see my screen.
Yes, we can.
Okay. Welcome everybody. I'm Federico. I work at Space for Good as a GIS and remote sensing specialist. What you see here is not the result of a fire, but it's the result of this bark beetle infestation. And bark beetles live and reproduce themselves in a living layer of the tree, and determining often the death of these trees. And in Europe, actually, we are assisting to massive bark beetle outbreaks due to climate change and to the change in the species composition. At Space for Good, we developed a model to analyze the risk of bark beetle outbreaks to facilitate forest management, and specifically we did it in Switzerland. How? With the use of satellite imagery, more specifically Sentinel-2, combined with weather data and with in situ information such as forest characteristics and geology. Please do not hesitate to contact me if you have extra information. We are active as well in the arena of deforestation and fire detection and biomass assessment. Thank you for the attention.
All right, thank you very much, Federico. Moving on now to Julia Yagüe of GMV, who will talk about My Sustainable Forests. So, Julia, the floor is yours. And
yes.
Federico, if you can unshare your screen, please.
Yep.
There we go.
Okay, good afternoon, and thank you for the opportunity. So I would like to present to you what we have done from our team led by GMB based in Madrid on my Sustainable Forest Horizon 2020 project, which is a go-to-market project. And I would like to present two things: the product portfolio and how to request the products which are laid in a web platform. So the portfolio consists in 21 products based on satellite, LiDAR, and sonic data. And the 21 products are arranged, well, around 6 services that follow the silviculture cycle of a forest. So here you have each one, the names of each one of the products and how they are linked to that silvicultural cycle. Each product, you can access them and see them fully described in the web page. And each product has a fact sheet with a full definition, all the technical details, and the applications in the cycle. All these products are produced by four of the partners and have been tested and validated, all of them, by other 6 stakeholders, members of the consortium. And we have been super careful in the validations and in presenting the results, which have been very, very good. Here you just have a sample for the clear cuts. And there also you will find the service request form. Very simple, in just one page you access it and give your details to enter into the platform, which is secured. And you will, the person or the institution or stakeholder or proprietor will access the details and the products requested. And here you will have further information about it. And with this, I thank you for your interest.
Okay, thank you very much, Julia, for putting a lot of information in a very short presentation. I know this is not easy. I would like to move over to our last speaker of today, Arnis Kadakovskis of the Institute of Electronics and Computer Science in Latvia. Arnis, assuming you're still with us, the floor is yours. Ah, yes, I can see you now. I can't hear you though, Arnis. Arnis, we don't hear you, I'm afraid.
Sorry, I found the unmute button, sorry.
Ah, there you go, that's much better. Okay, go right ahead.
Awesome. So yeah, hi, my name is Arnis and I'm with the remote sensing group at the EDI Research Institute in Riga, Latvia. At Project Woodstock, we're doing what many others are doing, estimating forest stand parameters using different combinations of satellite data and ground truth data. Our team of 10 is focused on novel unsupervised and self-supervised machine learning approaches for land cover classification. Basically, that's the big difference from our approach. And from users' perspective, this improves the performance where ground truth data is insufficient or deficient, be it sparse, biased, or incomplete. Those are typical problems in machine learning projects. And you were using a mix of open domain and commercial data, satellite data, to find the best combinations. And we're validating the approach with the largest forestries in Latvia. And we'd be happy to get to know more research and industry partners in the field. So please contact me for follow-up questions.
All right. Well, thank you very much, Arnis, and we'll make sure to spread this information to everyone who is and also everyone who has not been able to join us today. So thank you for that. With that, I have 2 more very short messages that I'd like to share with you before we close for today. And I will share my screen real quick for that. First of all, I would like to invite all of you to join us again next month on the webinar with Eurisy and GroundStation.space, where we will then focus on space for smart mobility. So quite different from today, but still within the space opportunities for climate challenges theme. Next month, Wednesday, the 7th of April at 4 o'clock. And then to close off for today, I would like very much to invite you to the Open Campus Forum, where from tomorrow morning onwards, you will find the replay of the webinar, plus links to all the recordings, and I will send you an email, a link to all the presentations. I will send you an email on how to get there. But if you want to join us already, please go on the groundstation.space website to the menu Open Campus, where you will find the forum and where you will find all the information about this and all our previous webinars. We have to ask you to register, just one-off, to become a member of the forum, which is completely free, of course. Then log in and then find today's topic, space opportunities for forestry, and you'll find all the information. And it's a forum, so it's really meant to interact, to ask questions, to add new topics that we maybe have not talked about today, and to share knowledge and to share your questions. Find partners, perhaps, to look at the calls that Linda talked about earlier, and anything really to form collaborations on the topic of space for forestry. So having said that, please meet us at the forum. If not, meet us next month. It still says here 3 March, sorry, that should say the 7th of April. Please stay in touch, groundstation.space and eurisy.eu. And thank you very much to our speakers for taking the time to share this information with us. And thank you very much to all participants for joining us and learning together with us. So thank you very much, and we'll talk to you next month. Goodbye.
Goodbye.